Here are 5 dumb mistakes that wreck your code that unfortunately most of you are making. Not only will I show them to you, but I'll also show you how to fix them in just a few seconds, so stick around. Mistake number 1 is lack of consistency. Have a look at this code right here, pause the video, and take a guess at what I'm going to say is wrong with it. Some of them are obvious, some of them not so much. Now, if you haven't paused the video, please go ahead and do that. I'm going to run through a lot of the mistakes that you can see that might be a little bit subtle, especially to a more beginner programmer. Let's start by having a look at the top of our code here where we have these 2 variables, message1 and message2. Now they seem innocent, but notice that we're using double quotation marks and single quotation marks. Now in a hobby project, this is completely fine, but when you get into larger code bases and working with other people, you want to make sure you're always using the same type of quotation marks or the same type of variable names. It doesn't really matter what you decide so long as you're always consistent. Inconsistency just makes really bad code, it makes it hard to predict, and it's something that we can easily avoid. Continuing, let's look at this variable. First of all, notice that we have this user profile and we're using camel case. Now in Python, you really should be using snake case like this. Anyways, that's one inconsistency. The other is with the different field names that we have inside of our dictionary. Notice that we have camel case, we have snake case, and then we have Pascal case. We really should be using the same type throughout all of our different field names to make it more predictable on what the field names will be. Continuing, we have a class here. Now notice in the class, we have some inconsistency with our spacing. We have no space separating these 2 methods, but we have a space separating this one. So what do we want to do? Simply add a space or add an indentation level. Quite simple. Okay, let's go down here to our DB manager. Now this is completely fine. We have a DB manager variable. We call our connect method, and then notice that we actually use the class to invoke this class method or this static method, and then we use the instance to invoke the static method again. Now this doesn't really make a lot of sense and again is an inconsistency. We have a static method. We can call it from either the class itself or from an instance. In this case, we're doing both one after another. We really should just stick to one way. I'd probably prefer to use the actual class itself, so database manager, but it doesn't matter what you want to do so long as you do it the same each time you do it. Continuing, we have some variables x and y. Now notice that we don't have a space between the equal sign. We can really easily clean that up by adding it there. Next, we have 2 constants, one of which has a capital, one of which is not in capitals. So again, doesn't matter what you decide to do here, just do it the same every single time so the code is more predictable. Lastly, we have a function here. Inside of the function, we're returning 2 different types. Here, we're returning an object. Here, we're returning a string. This makes it more difficult to work with the return type, and again, it's not consistent or predictable. Now we get into mistake number 2, which is not registering for my free software development course, which teaches you everything you need to get a software development job making $80K per year with no degree or experience required. Seriously, this is completely free. You can sign up for it from the link in the description. It's about an hour long and breaks down everything you need to do completely from the beginning, all of the things you need to learn, the curriculum you need to follow, and how you can break into the tech industry. Register from the link in the description completely for free. Seriously though, that leads me into mistake number 3, which is this code here. Before I reveal, take a second, pause the video, and see if you can tell me what's wrong with this code. Okay, I assume that you've paused the video. When we have a look at this code here, we can see that we have hard-coded values. Now notice this is just a simple game. If I actually were to run this code, let's go here and run it, Python example2.py, you can see that we can just move around and it's a little square on the screen. Okay, a simple game in Python. However, the issue with this is that we have all of the different values in our game hard-coded in. For example, we are setting the width and the height of the game by just putting in 800 and 600. We're determining the position of the player by dividing the width, which is 800, and the height, which is 600. Notice that we use these values consistently throughout the program. 600 here, 800 here. We now have a value like 50. You might not actually know what that is right away, but this is actually the width of the player, or the size of the player. You can see we use that down here when we're actually drawing the player. We have a color. This is actually white, which we're filling the screen with. Again, you might not know that because we don't have it stored in a variable. We have another color, which is the color of the player. We've got a bunch of hard-coded values, even things like 5 here, which is the velocity of the player. So notice that it's very difficult for me at first glance to understand what all of these values are. And if I want to change anything like the width of the screen, the height of the screen, the speed of the player, I've got to change this in multiple places. Now, this is a very simple example where we can get away with this, but imagine we had code that was thousands of lines long, and we were consistently using these values. Well, it would be an absolute nightmare to change them, to find them, and to understand what they're doing. So mistake number 3 here is using hard-coded values. Let's go to the fixed version of this code and you'll see how much better it looks. So here's the fixed version. Notice at the beginning of the program, I define all of my constant values, which previously were hard-coded. First of all, I now know what all of these values actually are. It's very easy for me to change them in one location, and as I read through the code, it immediately becomes a lot more readable and easier for me to understand. I now know what the player color is, the background color. I know that I have my height minus my player size. I know the velocity is this value right here. I know I'm dividing the width by 2, the height by 2. I know this is the width and the height. I have my FPS, like my frames per second. It's just much clearer, easier to understand, and obviously something you should do in your code. Now we move to mistake number 4. Again, pause the video, see if you can tell me what the mistake is. Well, looking at this code here, we can see that we have a bunch of different kind of conditions or criteria, right? We have income, is student, has coupon, has membership, etc. We then have a very complicated if statement, which aims to tell us if a student is eligible or not eligible for a certain offer, criteria, whatever it may be. Now, I challenge you, read this and tell me what the criteria actually is for a student to be eligible. Now, you probably can do that, but it's going to take you a minute or two. You're going to have to really look through this code. It's a bit difficult to actually understand. The reason for that is we're using a very complex Boolean expression that has a bunch of ands, a bunch of ors, a bunch of chain conditionals, and it's just very confusing. Now, it's really easy for us to clean this up by simply taking some of these more complex conditions and putting them inside of subconditions or variables that store a part of the condition. Let me show you what I mean. So now have a look at this code. It achieves the exact same thing as the previous code, except it's much easier to understand. Now, we've been very verbose here just for the purpose of the example, but you can see that what I've done is broken all of the different conditions into variables that describe what they are. For example, are we an adult? Well, that's the age greater than 18. Are we high income? That's the income being greater than 60,000. Are we medium income? Well, that's the income between 40 and 60,000. Are we an eligible student? You get the idea. Now, some of these seem obvious, but we're writing them in a way where it's very clear to understand, and anyone reading our code would have no doubt what it's doing. Now, to go a step further, we have some more complex conditions, right? Like eligible income. Well, the eligible income is if we have a high income or this specific condition is true. So we're kind of taking this condition and breaking it into smaller and smaller pieces, so it's really easy to combine it together and understand what it's doing. Eventually, we get down to the eligible offer, and we can now read exactly what the eligibility criteria is. It's if we're an adult, we have eligible income, and we have an eligible coupon. We can understand that in a matter of seconds versus minutes with the previous code. So moral of the story here is always break your complex conditions into smaller subconditions and then combine those with the variables that you have. Now we move on to the next dumb mistake, which is a super simple one, and this is unused imports. Guys, just remove your unused imports. If you're not using something, don't have it in the code. It makes it very confusing when you have a lot of imports or functions or parts of the code that aren't being used, whether it's a variable, class, function, import, doesn't matter. Remove it if it's not being used. You can always add it back. You can always go and look at the Git history. You can comment it out if you really need to, but preferably just completely remove it. In this case, you can see we're not using system, we're not using radians, we're not using random, we're not using time. If I were reading this code, I might think that we're doing some more complex stuff that we're really not doing because we have all these imports that aren't being used. Fortunately, the IDE is blurring them out. Just to give you a quick example, if we go here and we see what it looks like without the unused imports, a lot cleaner, a lot easier to understand, and just better code. Moving on to our last example, we have unnecessary nesting. Have a look at this code here, which is something that many of you have probably produced in your life. Oftentimes, when we want to write complex conditions or we have a lot of different things to check, what we end up doing is getting this huge chain of if statements. It could be for loops, it could be many other things, it could be functions, classes, whatever, but we end up getting really deep levels of nesting. Now, it's very difficult to read this code, maintain this code, and change anything inside of it, and it's really just unnecessary. We don't need to write code in this fashion. You can see that we're checking if data. Well, if we have if data, then we need to check if the name is in the data. Well, if the name is in the data, we need to check if we have a name. Then we need to check if it's alpha. Then we need to check if it's in the right length. You get the idea. Many beginner programmers think this is the only way to write code, but let me show you an alternative style that removes all of these levels of nesting that make your code really complex and hard to understand. Let's pop this open and notice that I have the exact same code that achieves the exact same thing, except I have no levels of nesting, or very few in this instance. Now, the way we can achieve that is by changing the way in which we think about checking conditions. Rather than checking if everything is true in that kind of chained nested statement, we instead check all of the things that could be false or would result in us not reaching the condition or the end goal, and then returning or exiting from the function. So in this case, we say, if not data, then we simply return, right? We say, okay, no data was provided, return. Next, we get the name. If we don't have a name, we say the name is empty and we return. So notice I'm checking all of the things that could be wrong. And then if all these things are not the case, that means I actually have the valid condition and I can go ahead and print out the valid name. So this is just the opposite way of doing things, right? So you're checking it in the reverse order. This allows you to exit the function early whenever you run into some potential issue, and you don't have to have these huge levels of nesting. I know this is a simple example. Obviously, there can be more complex cases, but I just wanted to show you that there's a different way of writing your code that removes those levels of nesting. And whenever you find yourself having 2, 3, 4, 5 levels of indentation or nesting, think about how you're writing it, and if you can write it in another way that will make it more clear, concise, and have less nesting. Anyways, that's going to wrap up this video. Don't forget to sign up for my free software development introduction course from the link in the description. I hope you guys enjoyed. If you did, leave a like, subscribe, and I will see you in the next one.